to today's new topic where we're doing, or chapter where we're doing vectors in 3D for linear algebra. Yeah, guys, I just wanted to also remind you to not forget to subscribe, to comment down on the videos so that I know that you guys are engaging with the content, and also like the videos. If possible, please do share with people you know might need the help. So 3D vectors basically operate the same way as 2D vectors. The new thing here would be, instead of working with the x and y, or rather this kind of positional vector, we now add the unit vector k to a vector. For example, if you have vector s and you have something like this. So before we would just have the unit vector I and unit vector k, J3, and now we have K. I forgot to insert like a picture or paste in a picture of what a 3D vector might look like, but I'm going to try to show it here on the screen somewhere. So let's talk about vector addition and subtraction, just like you would with 2D vectors. If you have vector S and vector P, S plus P would be, A plus E here, and then you have B plus F and C plus G. So this would be the vector addition of a 3D vector. Okay, now let's talk about vector subtraction, like you would with your 2D vectors. When you're subtracting, in this case, you would go A subtract E, and then B minus F. I don't have enough space, should have zoomed in. So you would have A minus E and B minus G, and what? B minus F, sorry, and C minus G. C minus G. And this would be your vector, right? Remember, a vector in this case, when you're dealing with a 3D vector, you would have 3 rows and only 1 column, because if you're converting it to this kind of ordered pair form, you might just want to have an ordered pair form, basically, like an ordered pair. Positional vectors, if you were supposed to write maybe vector S as a positional vector, okay, S is ABC. So positional vector of S would be your A plus B and plus C, right? And remember the unit vectors that you're supposed to have. So this would be your S, and then P would be EFG. So you would have vector P being equal to EI. So E plus F. Guys, I keep making mistakes here. F plus G and K, right? Remember, why you're having those unit vector forms, if you think of it, let's say for I, if I is here and I is 1, remember, I is 1 is to 0. If you think of the length of I, it's 1. Remember what the length of any unit vector is, it's forced to become 1, and hence why we denoting them as unit vectors. So just kind of remember that. Unit vector of S would be S, I think, was A, B, C over the magnitude of the vector S, right? So that would be that. Magnitude of P, obviously, even the unit vector of P, you find it the same way. Magnitude of P would be, so the, okay, I think let me use this. The magnitude of P would there now be, so P, I think, was E, so E squared plus F squared plus, I think it's G squared. So that would be the magnitude of P. And then determining that P and S are parallel, you can find the gradient of the vector P, and also find on the side the gradient of the vector S. If you want to, you can use unit vectors, and the taking out the magnitude aside would let you know if the two, or taking out a common vector within the vectors would let you know if the two are parallel, just like you would with 2D vectors. So, and then we want to know, what about multiplication? So we've been talking about addition, subtraction, magnitude, unit vectors, slopes, parallelity. We've been talking about all of those. So what about then being multiplied with each other, and that basically is your dot product, or your, yeah, in this case it's dot product. And then next time we will be talking about the cross product, where we're dealing with like matrices or determinants and stuff like that, right? So before cross product, I think I might have to go back to determinants and inverses for me to be able to go to cross product, really, but I'll see. So activities is to find, or if maybe S is this kind of vector and B is parallel to S, which tells us another thing. With the, so they're saying also B has the magnitude of 2, or thus the magnitude of the vector B is 2. We are asked to find B. Remember, if something is parallel to another thing, that means they can have a unit vector. So we can find the unit vector of S, and then because now B is parallel to S, so let me just try to show you what I mean. So we're going to find first the unit vector for S because they are parallel, and then after that take out the scalars of S outside, and then whatever vector we left with, we're going to use the magnitude of B to kind of multiply it in and have the unit vector of B, right? So S as the unit vector, I think, what was S? That's 10, 10, 8, and 12. So 10, 8, and 12. Let's really just find also the magnitude. So the magnitude 10 squared is 100. Okay, let me just work it out here. Did I just, what? So 100. 8 squared is 64. I think is 144. So that's really just, let me, so that's 2, so 244 plus 64. This is 8, that's 10 and 3. So this is 308, right? So I'm just going to erase everything here and write the 308. 308. Obviously you do have to show the steps. I really am not sure if I have enough space to do that, so hence I'm writing it like this. So if you want to, you can just write this as 308, and then you have the 10, the 8, and 12, right? Remember that this is 12. Taking out a common vector in this would help me basically know what vector can be parallel to this. So this would be, if I take out a common vector of whatever that goes in everything. So let me see. 4, I think. No, 4 doesn't go in that. Let's just do 2, actually. So if I were to take out 2 again as a common vector, I would have 5, 4, and 6, right? Yes, I think that's possible. Multiplying these two, I would have a 2 here up on top. A 2. Then I'm just going to move this 2 here. Right? So that's my unit vector. So this is basically the vector that we're looking for that's in the direction of S, right? And then because B is also parallel to S, that means B is this, but with the magnitude of 2. So now the vector B is, actually, let me do the unit vector of B. Remember, the unit vector of B is also this, but with the magnitude of B. Remember, a unit vector is any vector that's parallel to that. So if I'm told that B is parallel to S, that would mean that B also has kind of the same vector that it's parallel to, that's also parallel to S, which in this case is 5, 4, and 6. So 5, 4, and 6. And the magnitude of B we told is 2. So if I could write this as 1 over 2, 5, 4, 6. And finding B would basically be 5 over 2, 4 over 2, that's 2, and 6 over 2, that's 3. So that's basically B, and if you check, B is indeed parallel to S. Right? I think I did it correctly, I'm not sure, but it can be something like that. The next question is, vector A is this, vector B is that, and they are positional vectors, so we have to change these two to positional vectors kind of. So I'm just going to also do it here on the bottom. So A is 15, negative 1, and 5. So vector A is 15i, negative j, so you can write it as j, and 5. So plus 5k, and then b, or vector b, is 8, 7, negative 3. So 8, 7, negative 3k, right? So we did that, and then they're saying to us R is a vector parallel to AB. So we also have to find AB, and then they gave us what R's units is and points in the same direction. So it means we have to find the unit vector parallel to this, or the slope, but the slope wouldn't help us because it points in the same direction. Think what really a unit vector does, and then from then on we can find the vector R with its magnitude. So they're saying, oh, determine the positional vectors of A and B. We did that, so we're gonna get our 2 marks. They're saying we must find the vector AB. Remember how you find AB. I think I do have a recording for that. So AB is basically the vector B minus the vector A, which in this case, B is 8, 7, negative 3. And that's subtract 15, negative 1 and 5, 15, negative 1 and 5. I mean, you can just technically do it from here, just go like that. You can do that, but I just prefer it this way. So this is 8 minus 15, negative 3 minus 5, that's negative 8. And that's basically your vector AB. And then they're saying to us, find the magnitude of AB. AB's magnitude would be 7 squared plus 8 squared plus minus 8 squared. Remember, negatives don't really matter inside. If you're dealing with a squared, negatives don't matter, right? Also, remember to have everything in brackets to minimize the possibility of not recognizing where the negative is actually, right? So that's 49 plus 64 plus 64. I hope it's actually 64. That's 49 plus 128, and then 1, so 8. Okay, let me actually give over the 1 here. That's 17, and then 4 plus 2 is 6 plus 1 is 7, so 178. Don't know what the square root of that is, so I'm just gonna go units. I really need to learn how to convert big numbers into square roots, but it's fine. So we have found the magnitude. Now we have to find the unit vector in the direction of AB. So that would be AB's unit vector would be equal to, AB was 7, so 7, 8, and negative 8. And then the direction was 178. And then now finding the vector would be, I think, 7 over 1 square root of 178. And then you have the 8 over the square root of 178 and negative 8 over the square root of 178. Right? And then I think from there you'd be fine with the unit vector. And then now they say hence determine the vector R. So I'm just going to rewrite my unit vector. So AB is equal to 1 over 178. If you want to, you can write this as, I think, square root 178 all over 178. But I'm not sure if that's the correct way to write it, so I'm just going to stick on this. And then AB was 7, 8, negative 8. So, and then we told what R is. So R has a magnitude of 18. I think it has a magnitude of 18. So what I'm going to do now is basically check if I have a common vector here, which I don't. So we have now a vector that's parallel to both. So I'm just going to write vector that's parallel to both, which is the 7, 8, negative 8. So R would be 1 over 18. So let me write R 1 over 18, and then we have the 7, 8, negative 8. That's 7 over 1, 8, and then 8 over 18, negative 8 over 18. And obviously, if they can be simplified, do try to simplify your answers, right? And then they saying explain why infinitely many vectors are parallel to AB, but only one fits the specific conditions given, and that's because AB has its own magnitude, right? So you can write here the vector AB has its own magnitude, because remember, because of the magnitude of AB, vectors would differ, because now if you think of a unit vector, it can be long or short, right? So the magnitude of each vector makes it long or short, so hence why it can differ from many other vectors. And then I also wanted to highlight, can you see that these, so it's 2 plus 2, 4 marks, plus 3, 7, and then plus another 3, that's 10 marks. So instead of leading you on how to find your answer, so instead of leading you from maybe question 1 to question 5, they can just go straight to question 5 and say to you, determine the vector R. So you have to know, based off on reading these points here, how to find vector R, right? So you have to know things like your unit vectors and how to basically find vectors when given certain kinds of information. And I think that's it for the video. I just wanted to show you that you can find vectors using the unit vectors, or vectors that go in the same direction, and how to go about that. That's it for vectors in 3D. It's just basically what you would do in 2D, just an extension of that. Next time we're going to talk about the dot product and hopefully the projections as well, and then we're going to move on to the cross product, where we also learn how to find the determinants and inverses, not inverses, sorry, and the identity matrices.